A very good afternoon, and the definition of irony cannot escape me that I was much later coming to this event today than I wanted to be, because we've had two embankment slips this morning, one at Dewsbury and one more recently at Aycliffe, which is disrupting the East Coast Main Line at the moment. So this could not be a more topical discussion, and definitely the irony doesn't escape me or indeed my colleagues that I've come to talk to you today about this. So it's following on really from a lot of the topics that Matt covered, and really how we integrate that with actually running the railway. So I wanted to talk to you first, just a very brief overview of the route and my role and how we manage operations on the railway, and then how that integrates with our weather management and indeed incident management. So East Coast route, stating the obvious really, but King's Cross to the Scottish border, just the 338 miles of it, which looks on the map really simple. It's just one long line from one end to the other, but certainly in the last week it reminds us all that it can be quite brutal in its desire to be somewhat difficult and challenging in terms of both management of the infrastructure and management of the train service. The route control in York covers the East Coast route, King's Cross and branches, as I say, all the way up the East Coast. But importantly, the control also covers, as Matt's commented, the north and east areas. So south east, western and North Yorkshire, as was, Humberside, North Lincolnshire. And we're co-located in there with our three of our key train operating companies, LNER, GTR and Northern, dealing with many others, albeit that are located elsewhere. And from an operations perspective, signalling centres at Tyneside, Doncaster and the York Service Delivery Centre, plus a variety of single-staffed signal boxes and level crossings. Unfortunate, I've made a mess of the slide here, because actually underneath the bottom right of the picture is a reminder that we actually still have level crossing keepers on the East Coast Main Line, pushing wooden gates across whenever somebody wants to go across in their farmer. So we're by no means as modernised as some people will think we are in some senses. In other senses, we're obviously leading the way with digital railway and the evolution of having trains running without any line-side signals, which is a process that we're very involved in at the moment. But it's an interesting point, I think, that despite the fact we're leading the way with modernising the railway in many senses, we're also dealing, as you'll have heard about an awful lot, I think, today, with a Victorian, if not older, infrastructure. And the challenges that comes around that, again, as Matt's alluded to, are somewhat never-ending. So the battle is constant, and the need for us to improve how we respond to incidents and how we mitigate the risk from those incidents is really very important. So signalling staff throughout the route, operations response teams also form part of my team. So that's the mobile operations manager teams principally, which are located at the strategic points throughout the route, and they're generally the first eyes on at an incident. And indeed this morning we're very helpfully able to give us a live video link to an embankment slip site that's been discovered this morning, and that's crucial really for our engineering organisation to be able to decide A, what the level of risk is, and B, what we need to do about it, and see whether we can run trains. So I touched on it briefly, but the route control in York is the largest in the UK. It's on two operating floors. The main controls on the first floor. The Service Delivery Centre, which covers King's Cross to Peterborough, is on the second floor, which is an integrated operation with the signallers and the control team. There's actually about 100 staff that just work in the control centre, which some people say sounds an awful lot, but when you see it in action and see the variety of things that it has to cover, you sometimes wonder how they actually they do everything they need to do. And I've put a brief summary there of all the things that we deal with, not just weather, but a big part of weather and asset risk is understanding the risk in advance, so we can be as prepared for it as we need to be, both operationally and in terms of infrastructure response, and then indeed dealing with it afterwards when it happens. And I've just put a very brief summary here really of the core structure of the control. And this is quite important, because from a command and control perspective, the headline criteria that we have to manage is overall system risk. So that is about recognising what the problems are, understanding what the rules are and what processes we should and shouldn't be following, but then stepping back from that and looking at it from an overall system perspective, because inevitably you can't write a process and you can't write a rule to cover every eventuality. And that was certainly one of the challenges in the Carmont issue, amongst other topics that sometimes go wrong, which we'll come to. But in summary, there is a strategic lead in the control 24/7 who ultimately has the accountability on my behalf, really, and ultimately like route directors for running the railway safely and in compliance with our processes. There's tactical supervisors that report to that person, and then there's a suite of control staff. And the controllers are split into two core functions, really. The first is incident controllers that basically deal with anything and everything that goes wrong and is unplanned on the railway. And that can be an external event, can be a weather event, can be an infrastructure problem, it can be a train-borne event, it can be it can be a people problem or accident. So a huge range of anything and everything that either causes train delay or has the potential to cause train delay, they're responsible for managing, coordinating and mobilising staff to. And then the train running controllers that sit alongside them specifically don't do that. They're purely there to run the train service, and they coordinate with our train operating collies. They'll look at what options we've got for getting round things, for diverting things, and unfortunately are the people that press the button to cancel the trains when the train's cancelled home, but not without good reason, it has to be said. So what do we deal with? Oh, I've made this slide posher than I realised, actually, so I'll just get to the end and then talk through it. I didn't know I was going to do that. There you go. So I've just put some visuals here just to give a very brief indication, really, of the wide variety of things we deal with. But you can see there from a weather perspective, certainly on three of the slides, the flood risk site that Matt commented on is Kirkstall. I'm not sure which event that was, Matt, actually, on the right-hand side, but that was one of the sites just outside Leeds. The winds clearly brought trees and the associated overhead line down at the top there. Train fire, collision with a crossing. Very serious fire. You can just spot the signal box that managed to survive that fire. I don't know how, but it did. At Bradford a couple of years ago. And the snow. And I've put these together, actually, because I think not only are they quite a good illustration of the variety of things we deal with, but from a weather and an earthworks and an asset risk perspective, you can see there how, in actual fact, in two of those photos, in reality, we've got it wrong, because we've run trains there into a snowdrift, which we shouldn't have done and argued was predictable. And at the top, we, rightly or wrongly, have ended up in a situation where the strong winds have brought the overhead line down and trapped a train, and you can see there that we're having to evacuate passengers off that train. So ultimately, really, in terms of managing the network, it really is about us constantly assessing and understanding what the wider system risk is. And it would be really easy for Matt, I keep picking on you, Matt, because you just spoken, so I apologise. It would be really easy for Matt and many other colleagues to say to us, well, it's going to be wet, it's going to flood, there is a risk, and therefore you shouldn't run any trains at all for the next day, 2 days, 3 days through the next storm. At the same time, it would be quite easy for us from an operations lens to go, oh no, the passenger's more important, we're just going to keep running trains until it goes wrong. And the reality is, it's very difficult sometimes to get the balance between those two extremes of view. So we've worked very, very hard nationally, and certainly my team has been very involved in trying to get the protocols and the processes right that deliver the right balance for that. And that's really hard, isn't it? Because the first day that we say it's going to snow and it doesn't, and no trains run, it's all our fault. At the same time, that was one of the incidents that actually scared me, if I'm honest. That picture in the middle, we had passengers stranded on that train with no heating, lighting, or any way to get to them for several hours, and that can rapidly become a very, very serious situation. And so it's dead easy to say you should have run the train and got them home, but on this occasion they haven't got home. And they did, actually. They got on that engine that's alongside it, and we took them back on that, but that's by the by. And again, purely an illustration, really, but just a timely reminder, I think, that why do we do what we do? Why do any of us do what we do in this industry? Well, it's actually for the passengers. It's not for running the trains, it's not for performance, it's not for any other reason. It is for the passengers stood on the station. And one of the very important things I always ensure in the control is that we have the CCTV footage up, particularly of the top two, Leeds and King's Cross, so that when it's all going wrong, felt like every day in the last week, unfortunately, but when it's all going wrong, that's why we're doing it, and that's why it's so important that we get it right. And we do run as many trains as we can, but we do it safely. And again, there's just an illustration there, I think, of the variety of the network that we're dealing with and the variety of the passengers that we're dealing with, because you've clearly got the pressures of the main lines, King's Cross and Leeds, but you've got the other extremes, which actually causes a lot more of a headache from an asset perspective in terms of embankments, flooding, all that sort of thing. The Newcastle-Carlisle line is on the right-hand side there, which is one of our high-risk routes, which I'll come to, and the Whitby branch. And those two lines always come up on our calls when we're dealing with weather risk, because they are actually the routes that could really catch us out and could end up with a really nasty accident. So it's always, for us, it's always remembering that the route that's got 4 trains a day is potentially much more of a risk to us than the route that's got 4 trains a minute, because of the nature of the infrastructure. So in terms of weather risk and how we make sure we're ready to manage it, we do have an excellent weather forecasting system. It's a national process that Network Rail employ through the Met Desk. It produces us forecasts daily, and there's a 24/7 forecasting centre that we can call, and we often speak to them at length. And they produce us relatively simple, actually, risk-based colour-coded charts to tell us what the weather they think is going to do. And I have to say, they are very accurate, and they often disagree with what you see on the television, which can cause a bit of a problem, because we're confidently saying it's going to do this, and the BBC saying something else. But nonetheless, they do actually provide us a really useful forecast. And associated with the forecast, we have a live tool that gives us a whole host of data, both previous, current, and forecast, everything, wind, rain, snow, and everything in between. So it's an invaluable system for us. And then in terms of our processes, we enact, it's a bit old-fashioned, call it an EWAP process, but it's just what the process is called nationally. And it's designed to do 5 things, which I've listed in the centre there. Ensure our awareness of what the weather's going to do and the risks associated with it. How are we prepared to deal with that? And preparation is 2 things. How do we proactively mitigate the risk from running trains at all, running them at reduced speed, limiting the number of trains that are running, etc. And how are we prepared to respond to the likelihood of things going wrong? So response is the third bit. And again, Matt talked a lot about a lot of the process we have in learning from previous lessons. We know that Rotherham's going to flood. We have a process in place that proactively disconnects all the, for example, the S&T equipment, to make sure that actually if it does flood, it doesn't ruin all the equipment and we can recover the railway more quickly. How we're going to recover and how we're going to review. And then importantly, the capital convective analysis tool, which I often get tongue-tied on. So this was another process that we were quite sceptical of, I think it's fair to say, when it was introduced to the controls post-Carmont, very much a post-Carmont tool. And quite simply, it alerts to us when there is actual, so this isn't about forecasting, it's actual very intense convective rainfall over either a 1 or a 3 hour period. And one of the real advancements that we've done on our area, more so it has to be said than other areas, although they are following us, is some very close working with particularly our Earthworks colleague structures as well, to risk rank every section of route that we have from one end to the other in quite simple low, medium or high risk sections. And it's risk ranking, if it alarms, then dictates what we do with the train service. So if it's a high risk section, Newcastle to Carlisle's a great example, we immediately impose a restrictive speed restriction. And in the case of the CAP tool, it's a 40 mile an hour restrictive speed. And the reason for 40 is that that's been risk assessed nationally as the reasonable speed you can operate at, such that if you struck, for example, a landslide, there's a much reduced chance of derailment or indeed train overturning. So an awful lot of science gone into the use of this tool, and it does go off mainly in the convective rainfall season, but something that we were sceptical of, but actually has proved itself, and has proved itself quite dramatically. So the example on the left is at Bradway Tunnel, just south of Sheffield, where we had an extreme cat alert at 1837, which imposed the 40 mile an hour speed restriction. And at 1903, there was a report of a landslip at that location, which was a real, I think, impressive use of the system that potentially has mitigated a very serious incident there. And I've included on the right-hand side exactly the same scenario. That's actually not on our route, but I've shamelessly stolen from the south. It's on Wessex route. But exactly the situation occurred. The train, the window that this picture was taken out of was the first train through that section running at 40 miles an hour, as opposed to the line speed of 110 miles an hour, and has clearly come across a very serious asset failure indeed there. So in terms of how we manage the risk, particularly from a convective rainfall perspective, some really impressive outputs from a tool that's now used nationally. And then in terms of how severe some of these things are and how dramatic they can be, it would be wrong of me not to mention, to those that can remember it, 2013 at Hatfield Colliery, where we had the spoil slip, which was an exceptionally dramatic event, and I think probably one of the most probably one of the longest line closures for 5 months that I can remember in terms of the impact. And a good example, I could have shown you a picture of what's happened this morning at 2 locations actually in terms of earthwork failure. But I think what's crucial for us and what's so important is that it's increasingly less common that these things happen without us either knowing that there's a risk there, or at least understanding if it does happen, we have intelligence on the site. So we've had 2 events occur today, and it's early days, so I can't comment on them too much. But we know the history of them, so we know what the water's been doing, we know what the earthworks have been doing. And the good news about that is that we have ever-increasing confidence, I think, that if it does fail, we know how severe the failure risk is, and we can mitigate that through either closing the line proactively, putting watch people out to keep an eye on them, or reducing the speed of trains. So a very difficult balance before things go wrong, I think, to understand whether we should put speed restrictions on, whether we should close the railway, whether we should run trains normally. And often that does come down to some professional expert judgment, of which I often take a part with my team. And we do it as a team, but we look at it very carefully to say, what's the system risk? What's the evolving picture? And I think the 2 recent storms, Babette and Kieran, have been a really good example where actually we've had some really significant rainfall for Storm Kieran, got to get the order of them right, that didn't actually breach any of our processes for doing anything, really, reducing the speed of trains or putting any proactive restrictions in place. But what we did, and again, none of our processes told us to do this really, is look at what the evolving risk was because of the continued accumulation of rainfall and the risk to the water table. And we worked very closely with our earthworks teams to actually conclude we were going to put some speed restrictions on proactively over a small number of sites, but the ones that we actually thought there was a reasonable risk of through that period. So it's an interesting topic because you can process it to death if you're not careful, and you can get some very successful, I think the Capitol's a great example, some very successful results to mitigate the risk. But ultimately it actually also comes down to having people with the right competence and the right knowledge to be able to look at that wider system risk and be able to decide what the right thing to do is. It's quite helpful that previously you saw the figures for the delays for Storm Babette. Ironically, the reason the figures are so high, particularly for the East Coast, is because we managed to keep running trains, albeit at 5 mile an hour, through a very, very extensive flood site at Peascliff near Grantham. In reality, on paper, that site should have been closed. We managed to go through it, video through it with the cab of a train, and the relevant engineers got it reopened. And that was just about getting people home, but getting them home safely. Ironically, you get far more headline delay, far more disruption sometimes by keeping the trains going than not. Nevertheless, that is the right thing to do. So a topic that is certainly ever evolving and ever important. Again, we mentioned Baildon previously before, but Baildon, I think, was a really, really interesting example. 2 minutes, I'll have to be quick. Baildon was a really interesting example, actually, of where operations processes went wrong. So the report's online, and it's an interesting read for anybody that's interested in this. But Baildon was a textbook scenario where we had multiple reports of flooding A report of flooding came in from a member of the public. The controller dealt with it, advised the signaller. Then another report of flooding came in, but they didn't confirm exactly where the second report was. They got told the line had been washed away, which it had. And the assumption was we were dealing with the same location, and actually one was around the corner from the other. So we got staff to the first one, flooding had gone, we reopened the railway, and a train went over this site with the track in that state, and that could have ended up with a train rolling in somebody's garden, who promptly rang back and said, "You've just run a train over that problem I've just told you about." But a really, really simple mistake in a very pressured and busy environment that could so easily have led to disaster, and that really is what the RAIB reflected on. But it's always a reminder to me, and I use it an awful lot in briefs with my teams and cascading through, that it can always go wrong. So the need for diligence in how we manage these things and how we respond to them is obviously really, really important. And on that note, I shall go back to looking at my phone and see when we're going to fix the embankment slide. If you're heading north of York, please check before you travel, I'm sorry to say. There are some trains, but not ones.
Thank you.